All right, how's everybody today?
My allergies are killing me, but I'm happy.
Well, my voice is killing me, so sorry I'm not going to be able to talk very loud today. Uh, what's that, sir? Honey and tea? Really?
Yeah,
I'll
that's
try that when I get home.
what's it called? You're not gonna. Okay, I'm super excited because Okay, so you know that game I was talking about, Devil May Cry, like a while
Yes.
back. Okay, well it's coming out in 7 days, and I'm super hyped up for it. And they just released the final trailer for it, like yesterday, and then finally confirmed one of my favorite characters, and I'm so happy. I think
Oh,
it's gonna be
okay.
good.
Well, at least you're excited. Okay, so here's what we're going to go ahead and do today. For several days now, we've been talking about how to solve trig equations, and I thought it would be a good idea at the end of the week. Let's just go ahead and stop and actually get you guys to practice some of these more simple equations that we've been looking at. And I even went so far as to give you a specific number of blanks. The number of blanks is the number of answers that you should be getting. Okay, so this is going to be due before you leave today. I'm going to be taking it as a grade. So I will go ahead and work one problem with you guys, and then I will turn you loose, let you use your notes, let you work together to solve the others. So which one would you like to do together? I heard number 3. I heard the last one. 5. Okay. So far I've heard 3 and 5. So how many people want 3? How many people want 5? Okay. So let's go ahead and take a look at number 5. Okay, come on, Jimmy. Okay. So we're going to look at number 5. It says solve the following trig equation for all values of theta. So you'll notice number 5 does not give me an interval like numbers 1 through 4. So on number 5, we have to go ahead and write that general case that I was talking to you about yesterday. So what am I going to add to my answer? Okay. Am I going to go ahead and add 2 pi n, or am I going to add pi n? So let me go ahead and write both of these. So plus 2 pi n, or is it going to be plus pi n? What do you guys think? I heard a 2 pi. Okay. It is not 2 pi n. I'm going to be adding pi n. Why? What trig function do I have? Tangent. And what's the period of tangent? Pi. So only tangent and cotangent will you add pi into if you want all the infinite answers. Okay, for the other 4, their periods are 2 pi, so you would add 2 pi n. Now remember, you don't have to do this on the first 4 because you're given an interval. So you're going to be looking for those specific answers. Okay, so let's take a look at number 5. 2 tangent of x minus square root of 3. Let me write this here. 2 tangent of x minus the square root of 3 is equal to tangent of x. Okay. Now you'll notice we've got the one trig function. There's 2 of them, but think about what I've been showing you over the past couple of days. Just pretend that that trig function is a variable. I want to rewrite this whole equation so that it just says 1 tangent equals. So what term would you like me to move first? Okay, so Angel says subtract this tangent over here. So minus tangent of x minus tangent of x. Okay, those are going to cancel. So 2 tangent minus 1 tangent will be just a single tangent. Minus the square root of 3 is equal to 0. Okay. Now what? Add the square root of 3. So plus the square root of 3 plus the square root of 3. So tangent of x, okay, is equal to the square root of 3. And that's what we're looking for. Okay, so now I've got tangent of x is equal to the square root of 3. So I think we're going to go ahead and start to move away from the triangles and probably go ahead and start to focus more on the unit circle with these. But the graph is very helpful in the fact that it can help you figure out what quadrants you want to look at on the unit circle. So what kind of square root of 3 do I have here? Is it positive or negative? It's positive. So what quadrants will that tell me to focus on my grid? Where is tangent positive? What 2 quadrants? Okay, one, definitely the first one, and the third. Remember, the phrase goes, all students take calculus, right? So here, that T stands for tangent. So on my unit circle, I want to be looking specifically in quadrants 1 and 3. Is everybody okay with that? Okay, so I'm going to look at a unit circle. Got one right here. Now we have tangent of x is equal to the square root of 3. Now remember, what is tangent's ratio? It's always y divided by x. Okay, so I'm looking at all these ordered pairs in these two quadrants right here. I'm looking for the ordered pairs that when I take the y value and divide it by the x value, it's going to give me the square root of 3. Well, for example, I can already eliminate pi over 4 because what's square root of 2 over 2 divided by square root of 2 over 2? That's just 1. So see, I'm looking for the ordered pair where y divided by x would give me square root of 3. So it's got to be 30 or it's got to be 60. Which one do you think? 60? Okay, so let's take 60. So I'm going to take the y value, square root of 3 over 2, divided by 1/2. And what do we do when we divide by a fraction? So this is square root of 3 over 2 times 2 over 1. It does give me the square root of 3. So this is the location I'm looking for. Okay. See, now that we found that one, we could use that to help me find the other one in quadrant 3. So we definitely know it can't be 5 pi over 4. Should the other answer be 7 pi over 6 or 4 pi over 3? It should be 4 pi over 3. Again, I'm looking for that other coordinate where I take the y value, negative square root of 3 over 2, and divide it by negative 1/2. Now, what are the two negatives going to do? Cancel out and give me a positive, and see, that's exactly what we have right there. So those are my two answers. Okay. Now, because I'm not given an interval, I'm going to write the general form, right? So I'm going to take both of these, pi over 3 and 4 pi over 3. I'm going to come back over here. Let me erase this. So I'm going to say pi over 3 plus pi n. 4 pi over 3 plus pi n. Okay. Now remember, if you're given an interval like the first 4, you don't have to do this. You'll just give me the exact answers that you find. Now, how many blanks do I have, though? 1. And sometimes this is going to happen. We haven't seen one of these yet. Remember, n is an integer, right? That represents the number of times you're going to rotate. So n equals 1, that's 1 revolution. N equals 2, that's 2 revolutions. If it's negative 1, well, that just means you're going in the opposite direction, right? Well, take a look at this one because he's kind of unique. Okay, so if I keep adding multiples of pi to pi over 3, I'm going to get my answers, right? If I keep adding pi to 4 pi over 3, I'm going to get my answers. But look at what happens when I actually take n equals 1. 1 revolution. Pi over 3 plus pi. How would I add those together? Okay, I need a common denominator, right? It needs to be 3. So what's pi over 3 plus 3 pi over 3? Okay, but do you notice it? Okay, isn't the other one start at 4 pi over 3? Okay, so see, what we're saying here is that this one form would give me every answer that I would need if I continually rotated. Now, it wouldn't be wrong if I went ahead and put this here. It's just unnecessary. Okay, so really the only answer that I need to put is pi over 3 plus pi n. Okay. Now remember, adding 2 pi n, adding pi n, you will not do that to numbers 1 through 4. Okay. All you need to do is isolate the trig function and then basically look at your unit circle where you have that appropriate value. If it's cosine, you're looking for the x value. If it's sine, you're looking for the what value? Y value. And if it's tangent, like we did here, you want y divided by x. Okay. All right. So any questions? Now, this one was the only one. I will tell you that numbers 1 through 4, the number of blanks you have, that is the exact number of answers you should be giving me. Okay? All right, well, I'm going to go ahead and turn you guys loose. This is due before you take off today. Okay? It is due before you leave. So help each other out, and there we go.